We are going to discuss about Lewis structure of molecules. In the last video, we discussed how to write the Lewis symbol for an element. We write the symbol of the element and the valence electrons are put as dots around the symbol of the element. Now in this video, we are going to see how to write the Lewis symbol for molecules. Lewis structure of molecules. Now there are certain rules that we should know before we write the Lewis structure of a molecule. The rules are, the first rule is, when you get a molecule, the first thing that you have to do is to calculate the total number of valence electrons of atoms present in the molecule. Now the second rule is, if that molecule is an anion means negatively charged, you have to add the number of electrons, and if it is a cation means positively charged, we have to subtract the number of electrons. Now the third is, select the least electronegative atom, and that is made as the central atom, and we have to draw the skeletal structure of the molecule. Now to draw the skeletal structure of the molecule, you have not learned about the shapes of molecule. You will be learning in the next videos, but now you have to learn the molecules, the Lewis structures that is shown in this video. So the skeletal structure is there for all the molecules, so that we have to draw. Now the last rule is, you have to put a single bond between every two atoms and use the remaining pair of electron either for multiple bonding or show them as lone pair, so that octet of each atom is completed. So the last rule is, after writing, you have to, sometimes you have to move to multiple bonding, means sometimes you have to put a double or triple bond between the atoms, or sometimes we did not put a double or triple bond. So what will happen to those electrons? They will remain as lone pair of electrons around the atom. And after writing the Lewis structure, final step is, you have to check whether the octet around each atom is complete. That means whether each atom is getting 8 electrons around it. So these are the rules. So let's do examples for Lewis structure of molecules. The first example is CO. CO is carbon monoxide. Now, first step is to calculate the total number of valence electrons in CO. So, total number of valence electrons is equal to carbon. You know the number of valence electrons in carbon is 4, plus oxygen, number of valence electron is 6. So, 6 plus 4 is equal to 10 electrons. Now, next we have to write the skeletal structure, and this is a neutral molecule. There is no charge present in CO, so no need to add or subtract electron. Now the next step is to draw the skeletal structure. Skeletal structure means, in this case we have only two atoms, one is carbon, one is oxygen. So no need to find the most electronegative element in this case or the least electronegative element in this. We have to write carbon, oxygen. So the symbol of carbon is C and oxygen is O. Now after that, you have to put a single bond between both the atoms. So I am putting a single bond. Now the next is, now you know that one bond means how many electrons? 2 electrons. Now we have total 10 electrons. Now the next step, after drawing a single bond between the atoms, you complete the octet around the electronegative atom. Which is the most electronegative atom among carbon and oxygen? It is oxygen. So complete the octet around oxygen. So how many more electrons should I put for oxygen? Now I am going to show the electron with a cross sign here. So 1, 2, 3, 4, 5, 6. Now this bond is 7, 8. So the octet around oxygen is complete. Okay, now here we showed 8 electrons. Now how many more electrons are left out in the total number? 2 more electrons. So where will we put that 2 electron? Around carbon. Now if you count, you can see the total number of electron is 10. I'll count. This is 1, 2, 3, 4. The bond means third electron and fourth electron. 5, 6, 7, 8, 9, 10. 10 electrons. Now, if you look at the octet, or if you look at the octet completion, you can see that around carbon atom the octet is incomplete, because if you look at carbon, you can see carbon, around carbon it has only 1, 2, 3 and 4 electrons. Whereas oxygen, the octet is complete. It has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So, I told you, after writing the Levy structure, the octet around each atom must be completed. Each atom should have 8 electrons around it. Now, in this case, carbon don't have 8 electrons, it has only 4 electrons. So, what we have to do? We have to go to multiple bonding. Multiple bonding means, how will we show that multiple bonding? So, this is not the structure of Levy structure of CO. So, what we have to do? We have to show the multiple bonding. So, again CO. Now, one lone pair. If I take one lone pair, any one lone pair and move to this position, then it becomes a double bond. Now, again you can see how many electrons are deficient for carbon. It has only 4 electrons. It needs 4 more electrons. Now, when you shift one lone pair of electron from oxygen, it gets 2 more. Now, 2 more is needed. So, one more lone pair will be shifted to this. So, how many bonds between carbon and oxygen? Triple bond. Now, how many more electron is left on oxygen? One lone pair. And this carbon has again a lone pair. Now, you check the number of electrons around carbon and oxygen. This is around carbon. You can see 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. One bond means 2 electrons. So, 8 electrons. Octet around carbon is complete. Now, look at the octet around oxygen. Oxygen has 1, 2. Again, we have 3, 4, 5, 6, 7, 8. 8 electrons. Now, you count the total number of electrons in both. Here we have total triple bond, 6 electrons. Then here we have 2 electrons. Then here again from oxygen, lone pair, we have 2 electrons. What is the total number? 10 electrons. So, what is the Levy structure of CO or carbon monoxide molecule? It is C triple bond O with a lone pair on oxygen and a lone pair on carbon. So, this is the Levy structure of carbon monoxide. Now, the next example is example 2. NO2 minus ion. NO2 minus, its name is nitrite ion. Nitrite. Nitrate is NO3 minus. Here I have written NO2 minus. Now you are asked to draw what? The Levy structure of nitrite ion. What's the first step? Calculate the total number of valence electrons in NO2 minus. So first step is total number of valence electron is equal to nitrogen. The number of valence electron is 5. Plus, we have 2 atoms of oxygen. So, 2 into the valence electron in oxygen is 6. So, we have 6 into 2 plus it's an ion. Minus charge means you have to add how many electrons? 1 electron. It is minus 1. So, plus 1. Minus means gaining of electrons. So, you have to add 1. Now, what is the answer? 6 2s are 12. 12 plus 1, 13. 13 plus 5. You get it as 18. 18 electrons. So, this is the total number of electrons in NO2 minus. Now, next step is to draw the skeletal structure. Now, NO2 minus, we have 3 atoms. So, which is the least electronegative atom? Nitrogen. So, that will come as the central atom. So, how will you write that NO2 minus? Nitrogen as the central atom and 2 oxygen we have on both sides. Okay. Now, next step is to put a single bond between each atom. So, I am going to put a single bond between this and this. Next, I told you, you complete the octet around the most electronegative atom. Which is the most electronegative atom? Oxygen. So, I am going to complete the octet around oxygen. Already it has 2 electrons. So, 3, 4, 5, 6, 7, 8. Now, this oxygen, 2 electrons are there. Now, 3, 4, 5, 6, 7, 8. So, the octet around oxygen is complete, and after completing the octet around oxygen, you can see how many electrons are used now. 8 plus 8, 16. Total number of electrons is 18, which means 2 more electrons are left. So, where will you put that 2 electrons? Around nitrogen. Now, you check the octet around nitrogen. Octet around nitrogen is incomplete. You can see around nitrogen atom we have 1, 2, 3, 4, 5, 6 electrons, which means what we have to do? We have to move to multiple bonding. Now already it has 6 electrons, nitrogen. How many more electrons are needed? 2 more electrons are needed. Means we have to put a double bond. Now when you show that electrons, that movement of electron, either you can move electron from this oxygen, or you can move electron from this oxygen. This is, suppose I give this as first and second oxygen number, then you can take electron from the second oxygen also. So you will get 2 types of structures. You can have 2 possible Levy structure for NO2 minus. Which are the 2 possible Levy structure? First will be, I am going to show from this oxygen. First oxygen I am going to move and lone pair of electron between oxygen and nitrogen. What will be the structure? O, single bond will become double bond, N, single bond, O. Now complete the octet around oxygen, 4 electrons, nitrogen, 2 electrons. This oxygen, we have not moved the electrons, so this. Now you check the total number of electrons. This oxygen, you can see 1, 2, 3, 4, 5, 6, 7, 8. So 8 electrons. Octet is complete. Nitrogen, you can count 1, 2, then 3, 4, 5, 6, 7, 8. Octet is complete. Now for this oxygen, you can count 1, 2, 3, 4, 5, 6, 7, 8. Octet is complete. Now you check the number of electrons, total number of electrons in this. Now, if you check, you can see 2 plus 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Total number of valence electrons is 18. Now one more thing, you have to mark this as minus because it is NO2 minus. Okay. Now this is one possible Levy structure. So you can draw the Levy structure of NO2 minus as this. Or what is the next option? What is the next possible Levy structure? The second oxygen can share its electron for multiple bonding. So what will be the structure, the Levy structure? Other possible Levy structure is O, single bond N, double bond O. Now this oxygen has 1, 2, 3, 4, 5, 6, 7, 8. That one bond pair is 7, 8. Now nitrogen, you know, again 8 octet is complete. This oxygen will have only 2 lone pairs around it. Okay, so again don't forget you have to put minus because it is NO2 minus ion. So this is the Levy structure. So you can show either this or this as the Levy structure for NO2 minus. Now the next example is carbonate ion. What's the formula of carbonate ion? So example 3 is CO3 2 minus carbonate ion. Now let's calculate the total number of valence electrons in carbonate ion. So what's the total number of valence electrons? Total number of valence electrons. Carbon 4 plus 3 into 6. Oxygen valence electron is 6 plus 2 because it is 2 minus. So what is the answer? 6 into 3. 6 3s are 18, 19, 20. We have total 20 plus 4, 24 electrons. Now we are going to draw CO3 2 minus. We have to draw the skeletal structure. Now the less electronegative element in carbon and oxygen is carbon. So I'll write carbon here. Now we have to draw the skeletal shape. I told you the shapes you will learn only later. So I'm going to show we have 3 oxygen atoms and the shape is like this. O, O, O. Now next we have to complete the octet around the most electronegative atom, that is the oxygen atom. So I'm going to complete it. 1, 2, 3, 4, 5, 6, 7, 8, this bond. Now this oxygen 1, 2, 3, 4, 5, 6, 7, 8. Now this oxygen 1, 2, 3, 4, 5, 6, 7, 8, this bond. Now if I write like this, look at carbon atom, the octet around oxygen is complete. But the octet around carbon is incomplete. You can see carbon has how many electrons around it. Now this bond will be 1, 2, this will be 3, 4, 5, 6. Only 6 electrons around carbon. But total we have 24 electrons. 8, 8, 8. 8 threes are 24 electrons. So to complete the octet around carbon, what we have to do? We have to move to multiple bonding. Now carbon needs how many more electrons? 2 more electrons, and the 2 electrons can be donated by any of the 3 oxygen atoms. So either this oxygen, if this donates or if this shares the lone pair, then we will have a double bond here. If this oxygen shares a lone pair, we will have a double bond here. If this oxygen shares a lone pair, we will have a double bond here. So how many possible Levy structures for carbonate ion? We can have 3 possible Levy structures. So I'm going to draw the 3 possible Levy structures. The first structure is COOO, CO3, 2 minus. Again, we have to complete the octet. Don't forget to complete the octet. 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. 1, 2, 3, 4, 5, 6, 7. So this is one possible Levy structure. Or what is the next possible Levy structure? The double bond can be here. Then it will be a single bond here, single bond here. CO3, 2 minus, and complete the octet around oxygen. Total 8. Now here 1, 2, 3, 4. Total 8. Here total 8. Now you can see the octet around carbon is also complete. 1, 2, 3, 4, 5, 6, 7, 8. 4 bond pairs means 8 electrons. Or again you can have the multiple bond on the next oxygen, between oxygen and carbon. So COO, you can have a multiple bond here. CO3, 2 minus. Don't forget to put the charge. Now complete the octet around oxygen. 8 electrons, 8 electrons, 8 electrons. So if you draw either this or this or this, it is all Levy structure for carbonate ion. Okay, now the next example is H2O2. What is the name of H2O2? Hydrogen peroxide. Example 4 is H2O2, hydrogen peroxide. First step is to calculate the total number of valence electrons. So total number of valence electrons will be hydrogen 1 into 2 plus oxygen we have 6 into 2. So total 18 electrons. Now, sorry, 2, 6 2s are 12, sorry, 13, 14 electrons total. Not 18. 12 plus 2, 14 electrons. Now we are going to show the skeletal structure. Here we know that hydrogen and oxygen is present. Now this hydrogen peroxide, when we have to show it like this, the skeletal structure HOOH. Usually we write the least electronegative atom as the central atom, but here we are writing OO because hydrogen peroxide has OH bonds present in it. Okay, now the next step is to put a single bond between each atom. Now complete the octet around the most electronegative atom. Which is the most electronegative atom? Oxygen. So I am going to complete the octet around oxygen. Now look at this oxygen. Its octet is complete. If you count the number of electrons, 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons for this oxygen. Now complete the octet around this oxygen. So 1, 2, 3, 4. Now if you look at this oxygen, its octet is complete. That is 1, 2, 3, 4, 5, 6, 7, 8. 7 and 8. Okay. Now you can see total how many electrons? We have 14 electrons. If you count the total number of electrons, it will be 1, 2. You have to count the bond pair and lone pair also. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 electrons. So this is the Levy structure of hydrogen peroxide. Now next is example 5. It is O3. O3 is ozone molecule. Ozone. Now what's the total number of valence electrons in ozone molecule? Total number of valence electron will be equal to oxygen, 3 atoms of oxygen into 6. We have total 18 electrons. Now let's draw the structure, the skeletal structure. It is all oxygen. Now it has an angular shape. So OOO. So the skeletal structure you cannot change. You have to draw it as such. The shape of ozone is bent shape. Now OOO. Okay. Now you complete the octet. We have 18 electrons. So complete the octet. 1, 2, 3, 4. 5, 6, 7, 8. Now if you complete around this 1, 2, 3, 4, 5, 6, 7, 8. Now 8 plus 8, 16. Now 2 more electrons left that we will put on this oxygen. But you can see that the octet around the central oxygen is incomplete. It has only 6 electrons. So what has to be done? We have to move to multiple bonding. That electron pair can be shared by this oxygen or by this oxygen. So you have how many possible Levy structures? 2 possible Levy structures. One is this. And complete the octet around oxygen. 1, 2, 3, 4. Now this oxygen. This is one structure, one Levy structure. Check the total number. It should be 18. 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 electrons. Or you can show the structure of ozone as, what's the other possible structure? The double bond, changing its position. Okay, now here complete the octet around each oxygen. Now this oxygen, so this is ozone. Now the next example is HNO3. HNO3 is nitric acid. HNO3. First let's calculate the total number of valence electrons in nitric acid. So total number of valence electrons is equal to, now hydrogen 1, nitrogen 5, oxygen 3 into 6. So total will be 24 electrons. Now nitric acid, the skeletal structure is, we know that nitrogen is the least electronegative element. So it will be O, N, O, O, H. Now in nitric acid there will be a OH bond. Okay, so draw and study the skeletal structure. Now next step is to complete the octet around the most electronegative atom, that is oxygen. So I am going to complete the octet around oxygen. This is completed. 3, 4, 5. No, here we need only 1, 2, 3, 4, 5, 6, 7, 8. Octet is completed. Now if you count, you can see there are 24 electrons in total. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, including the bond and lone pair. Now if we look at hydrogen, its octet is complete. We know that hydrogen needs only 2 electrons. That is, it is completing its octet with the help of this bond pair. Now nitrogen, if you look, its octet is incomplete because there are only 6 electrons around it. So what will have to be done? We have to move to multiple bonding. So how will you show that multiple bonding? Multiple bonding, any one oxygen out of these three, and usually we will not have N double bond OH. Okay, because it is like we will not have that N double bond OH. So either this oxygen or this oxygen can share its lone pair, but not this oxygen. Okay, OH oxygen, it will not form a double bond with nitrogen. So how can we show the possible Lewis structure? First is O double bond N, single bond O, single bond OH, and complete the octet. 1, 2, 3, 4, 5, 6, 7, 8. This oxygen 3, 4, 5, 6, 7, 8. Nitrogen, the octet is complete. This oxygen 1, 2, 3, 4. Or what is the other possibility? Other possibility is O, single bond N, double bond O, single bond OH. Now complete the octet. 1, 2, 3, 4, 5, 6. This oxygen 1, 2, 3, 4. This oxygen 1, 2, 3, 4. Now if you count, the total number of electrons will be 24. 8 plus 8, 16, 17, 18, 19, 20, 21, 22, 23, 24. So this is the structure, and remember there is no double bond here. That is OH attached, that oxygen attached to the central atom, we cannot put a double bond. Okay, only the other two oxygen will be capable of sharing the lone pair. So this is HNO3. Now the next example is H2S. H2S is hydrogen sulfide, and let's calculate the total number of valence electrons. Total number of valence electrons will be equal to 2 into 1 plus 6, which is equal to 8. Now the sulfur will come in the middle and hydrogen on both sides. Now put a single bond. This is the skeletal structure. Now complete the octet around sulfur. Sulfur already it has 4 electrons. Now 4 more electrons needed. Hydrogen octet is already complete because hydrogen needs only 2 electrons to complete the octet. Now if you check, the total number is 8. Number of electrons 2, 3, 4, 5, 6, 7, 8. So this is the structure, Lewis structure of hydrogen sulfide. Now the next example is BeF2, beryllium fluoride, BeF2. Let's calculate the total number of electrons. Beryllium is in second group, so valence electron is 2 plus 2 fluorine atoms into 7. Total number of valence electron in fluorine is 7. 7 2s are 14, 15, 16. So total we have 16 electrons. Okay, now the let's draw beryllium. It has a linear structure again, BeF2. Now complete the octet around fluorine. 1, 2, 3, 4, 5, 6, 7, 8. Fluorine 1, 2, 3, 4, 5, 6, 7, 8. Now if you check the total number of electrons, this is 16. So in this case you can see the central atom, that is beryllium, has only 4 electrons around it. One bond pair, and this is the second bond pair. Means the octet is incomplete around this central atom. Okay, so this is a very important case, that is an exceptional case, which is a limitation of this octet rule. That is incomplete octet around the central atom. This is an example for that incomplete octet around the central atom. You can see the central atom is beryllium. It has no 8 electrons. It has only 4 electrons. Okay, so this is one example for that. So note this molecule. Now the next example is HCOOH. When you see COOH, this is an organic acid, carboxylic acid. Now, you know the total number of valence electrons in this is hydrogen. You know there are 2 hydrogen atoms. So 2 plus carbon 4 plus 2 into 6. There are 2 oxygen atoms, total 18. Now the structure of COOH you have learned in class 10. C double bond O, single bond O, OH. Now we have one more hydrogen So that will be here. Now you check the oxygen. This oxygen octet 1, 2, 3, 4, 5, 6, 7, 8. This oxygen 8 electrons completed. Carbon octet is complete. Hydrogen needs only 2 electrons, so that's also completed. Check the total number of electrons is 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 electrons. Now next we have Sicl4, silicon tetrachloride. So this is the Lewis structure of HCOH. HCOH name is methanoic acid. Now next we have example Sicl4, silicon tetrachloride. Now the total number of electrons, silicon is in 14th group, so 4 electrons valence plus 4 chlorine atom into 7 valence electrons in chlorine. So total we have 32 electrons. Now let's draw the skeletal structure of Sicl4, silicon at the center and Sicl4. This is the structure. Now we can see the central atom silicon octet is complete with 4 bone pairs. Now look at chlorine. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8 fours are 32 electrons. So this is the Lewis structure of Sicl4. Now we have one more compound, that is sulfate ion. The last example is sulfate ion. Sulfate ion formula is SO4 2 minus. Now let's calculate the total number of electrons. Sulfur, it is 6 plus 4 oxygen atom into 6 minus 2 means we have to add 2 electrons. So 24, 25, 26, 26 plus 6 plus 2. So 6 fours are 24, 25, 26, 26 plus 6 will be 32. 32 electrons. Now let's draw the structure of sulfate ion. Sulfate ion will be SO4. SO4 2 minus. Now let's complete the octet around oxygen. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. Now you can see 8 fours are 32. And don't forget you have to put 2 minus here because it is sulfate ion. So these are the examples for the Lewis structure of molecules. Now next I have written here a question. Use Lewis symbol to show electron transfer between the following atoms to form cation and anion. The first question is A, potassium and sulfur. We know that potassium and sulfur, they will combine to form a compound, potassium sulfide. And what will be the formula of potassium sulfide? It will be K2S. So you have to show the formation of this compound using Lewis symbol. So Lewis symbol means how will we show? We are representing the valence electron as dot around the symbol of the element. Now here potassium, we have 2 potassium. So you will write it as 2K. Okay, with 1 electron. Potassium has only 1 electron plus sulfur. How many electrons around sulfur? 1, 2, 3, 4, 5, 6 electrons around sulfur. So this 2K means, or you can show it like this. K, 1K plus 1K. Now both will donate because sulfur needs 2 more electrons to complete the octet. So both will donate these electrons to sulfur. So what will be the compound formed? It will be 2K plus, this is the cation, and S with 1, 2, 3, 4, 5, 6, 7, 8, S2 minus. So you are asked to show the formation of cations and anions using Lewis symbol. So 2K plus S2 minus. Now the question B is calcium and oxygen. You know, calcium and oxygen combine to form calcium oxide. And let's show the formation of cation and anion. Calcium has 2 valence electrons plus oxygen has 1, 2, 3, 4, 5, 6 valence electron. So the 2 valence electron of calcium is donated to oxygen. You get calcium oxide. Calcium on losing electron, it gets Ca2 plus, and oxygen, it gains 2 electrons. So how will you show? 1, 2, 3, 4, 5, 6, 7, 8, 2 minus. Now the third compound is between aluminium and nitrogen. Aluminium and nitrogen combine to form aluminium nitride. You know that aluminium valency is 3 and nitrogen also can show 3 valency 3. So Al 3N3. We will not write 3, instead we will write it as ALN. Now let's see the Lewis symbol. Aluminium has 3 valence electron, 1, 2, 3. And nitrogen has 5 valence electron, 1, 2, 3, 4, 5. Now what will aluminium do? It will donate all the 3 electrons to nitrogen. So aluminium on losing electron, it becomes Al 3 plus, and nitrogen will gain 1, 2, 3, 4, 5, 6, 7, 8 octet, and it gets 3 minus. So this is how you have to show the formation of cation and anion using the Lewis symbol. So with this we complete the Lewis structure of molecules. Thank you.